All right, so looks like some people are joining in. We'll start in a minute. The end. I'm going to start with these guys. The meaty stuff, the hard stuff, the fun stuff. And then, God, there's a lot of multiple choice. So, I'm not going to do all these multiple choice. This is so many. If you have any questions specifically, text me on Remind, and I'll answer them as best as I can. Be specific. I did this last night with my other classes, and it was like, what'd you put for that one? And I don't know what that meant, so just say like, wait, can you do 42 again? Can you do 7 again? How did you do 7? Something like that. But we're going to start down here and do the short answer first. And then pick some rando multiple choice. And that's it. Call it a night. So, hopefully that link works. Should be good. People are joining in. You can send me questions on Remind. We're going to start with the short answer. Test tomorrow. Right now it's about 28 multiple choice and a handful of short answer questions. Some extremely short, 1 sentence, 1 number answer. Some of them are a bit longer, like the limiting reactants ones and stuff like that. Actually, when I start, I'm going to add something here. No, I want notability. There we go. I'm going to add something here to the top one. I'm going to add net ionic, because I want to review that, because that seemed to have escaped our memory. So, I'm going to get started right now. I think now's a good time to start. Hopefully we're all good. Please message me on Remind if something is off. And we'll get going. All right. Okay, so first, predicting products. Useful skill, gotta know how to do it. First thing I do is go down and identify the type of reaction you have, because if you don't know what type of reaction you have, you're not really going to know how to predict the products very well. And there's 3 main ones we predict products for. We got combustion, single and double replacement. We don't really do decomp. We don't really do synthesis because it's not too difficult, but there's a lot more in play there to predict those. That just makes this a little bit more than what it needs to be. So as I go down, the first one I know is double replacement, which means, or how did I tell it was double replacement? It's because I got 2 compounds, 2 ionic compounds specifically, where I know I have my sodium that's charged +1. I'm going to zoom in a little here. My sodium is charged +1. PO4 is phosphate. It's one of the ones on table F that you need to know, and its charge. That's -3. And Mg is magnesium, which is +2, and CrO4 is chromate, which is -2. From here, you take the 2 positive ones or the 2 negative ones, however you want to imagine it, doesn't matter. But take the 2 ones that are the same charge, not the same number, and switch them with each other. So, we got now Na is with CrO4, and Mg is with PO4. That's step 1. Step 2, crisscross applesauce those charges. So Na was +1, CrO4 was -2. So I got to put a little 2 by Na to balance that formula. Mg was charged +2. PO4 was charged -3. So I got to crisscross those to balance that formula. Now we got to balance the equation. So I take a look back here, I'm going to erase this. Erase you, because you're going to get in the way. And if I look at this, I'm going to start with sodium. So sodium, I got 2 here. I have 3 there. You got to find the number they can both multiply into, which is 6. So I'm going to 2 there. 2 times 3 is 6. I'm going to put a 3 there. 3 times 2 is 6. Now, if you have these polyatomic ions, aka phosphate and chromate, sometimes it's easier to just balance those as their own separate thing instead of like looking at the P's and looking at the CR's and looking at the O's. So I'm going to treat CrO4 as its own species, and I got 3 of them on the right side and only 1 on the left. So I know I need to put a 3 here. And that should be it. So I got 2 phosphates here. I got 2 phosphates there. I got 3 Mg's here. I got 3 Mg's there. Put a 1 there if you want. You don't have to, but you can if it makes you feel good. So, boom. Products, done. Formulas, done. Balanced, done. Now we need to figure out which one is insoluble, which for you, because I didn't make you memorize it, is going to be on table F, which will be redacted, and wow, I clearly did a lot of table F last night. So let's erase all this nonsense. So table F, as you'll notice, is mainly organized by your negatively charged ions, because they're all pretty much negative except right here. And you can approach this 2 ways. You can say to yourself, oh, anything with sodium in it is always good because it's in group 1, so you can just ignore anything sodium is bonded to because it's going to be soluble. Or you can take the negatively charged one and look at phosphate, which is insoluble unless it's with anything from group 1 or ammonium. And if I remember correctly, we were with Mg here, and Mg is in group 2. So, who's insoluble? Mg is insoluble. So I'm just going to highlight it. Insoluble. So, step 15. Who knows what step we're on? You're probably going to have a question on net ionic equations. Your net ionic equation is taking the 2 ions in your solid, aka insoluble product, and showing just the balanced mini reaction that's occurring. Because sodium and chromate, since they're soluble on both sides, aren't reacting, so they're just spectators. They're just floating around in solution, water, watching these 2 guys, Mg and PO4, form this solid product, and it drops to the bottom, aka a precipitate. So, balanced half reaction, net ionic equation. We got 3 Mg's, put its charge because it's an ion. We have 2 PO4s, put its charge because it's an ion. Makes Mg, I'm going to run out of room, Mg 3 PO4 2 solid. And that is your net ionic equation. Okay. Race. Next one you need to be able to predict. If you look at that reaction there, you have a hydrocarbon, aka a CH reactant with oxygen. Your mind should go combustion every time. Combustion always makes carbon dioxide and water. Don't look at anything. Write those 2 down. Balance this equation. I see 3 carbons. I see 8 hydrogens. 4 times 2 is 8. And then I see 3 times 2 oxygens plus 4. So that's 6 plus 4 is 10. Put a 5 there. Don't circle anything. There's nothing about solubility with combustion. You get carbon dioxide going into the air as a gas. You get water, might form a liquid, probably not because these are really hot, going into the air as a gas, done. That's combustion. Last one. When you see an element and a compound together, your mind should go single replacement. In which case, you should, 1, before you do anything, immediately flip it on over to table J and find the 2 atoms that you are going to compare. And I'm going to compare Mg and Na, because those are the 2 metals that are in my reaction. If you shared 2 nonmetals in your reaction, look at the other side for fluorine, chlorine, bromine, and iodine. The trick here with table J, if the one that is alone, the one that is not in the compound, is more chemically active than the one in the compound, this reaction will occur. And in this case, sodium is more chemically active than magnesium. And since it is, sodium is going to come in and kick off magnesium and bond to sulfate in its place. Check your charges, crisscross your charges. Sulfate has a charge of -2. Balance your formula. Balance your equation. 2. Don't check table F. Insoluble is for double replacement only. Do not concern yourself with single replacement insolubility. That's it. That's the basics of predictions. So if you could do any of these 3, you should theoretically be okay tomorrow, barring any goofiness. Next, limiting reagents, everyone's favorite. If there's one problem we do in class that everyone's like, Mr. G, please give us more, it's limiting reactants. So, there's 2 things at play here. 1, get the limiting reactant. 2, answer the question based on your limiting reactant. And this one was a little bit different than what we've been doing, but the process is the same. So, first thing we had to do is figure out how much iron was produced if you react 7 kilograms of iron 3 oxide and 3 kilograms of carbon monoxide. And at first glance, you might not think this is a limiting reactant problem, but to do this, you have to figure out which one is your limiting reactant, because you might run out of the iron oxide first, and then the reaction stops. Or you might run out of the carbon monoxide first, and the reaction stops. You don't know which one you're going to run out of first. So the first step is, who's limiting? And the first thing you got to do is figure out how many moles 7 kilograms of iron 3 oxide is. So 7 kilograms is 7,000 grams of iron 3 oxide. A really quick way to convert to moles from mass, you can set up your proportion, do your thing, that's fine. If you just take the mass given and divide it by its periodic mass or its gram formula mass or its molar mass, they all mean the same thing. In which case iron 3 oxide should weigh about 160, rounded, because I did 56 for iron, and 3 oxygen is about 48. So 7,000 divided by 160 is 43 point, I'll just round up, 8 moles. I'm going to divide it by again, just to show you the step, just to make sure we don't forget that you also need to take this into consideration. But there's a 1 here, so divide it by 1, the coefficient in the reaction. We have 43.8 moles. Moles tells you everything. You can't do anything unless you get moles. Carbon monoxide, we got to convert that to moles now. And if it's less than iron 3 oxide, carbon monoxide is our limiting. If it's more than iron 3 oxide is our limiting. And then we can take that and determine how much iron we're going to make in kilograms in this case. So we got 3,000 grams of carbon monoxide. And your key, I did it divided by 30 because I did 16 plus 12 in my head was 30. Don't ask. Carbon monoxide is a gram molecular weight of 28. And when you get that, you get 107 moles. Which at first glance, you might say, oh, iron 3 oxides are limiting reagent. But we have 3 carbon monoxides we need to use. So we have to react 3 carbon monoxides for every 1 iron 3 oxide. So it's 1, 2, 3, 1 iron. 1, 2, 3, 1 iron oxide. 1, 2, 3, 1 iron oxide. So I got to divide this by 3 so I know in my head how much carbon monoxide I'm actually using per iron 3 oxide. And when you do that, you get 35.7 moles. So that's less than 43.8. So I'm going to run out of my 3,000 grams of carbon monoxide before I run out of my 7,000 grams of iron 3 oxide. So CO is our limiting reactant, or limiting reagent, or whatever you want to call it. So now I recommend you start from scratch once you determine your limiting reactant, because some of you are going to incorrectly use this, some of you are going to incorrectly use that, or be confused, so wait, now which number do I use to figure out how much iron I make? Then I would say just start over and set it up and go straight through. So, I'm just going to erase some of this. Bloop. What's up?
Nothing.
Sarpa coming in?
No, I'm just getting a charger.
Sure. Say hi, Mrs. G.
What's up, guys?
3,000 grams carbon monoxide divided by 28 was 107 moles of carbon monoxide, right? Yep, that's what I got in my calculator. So the reaction has 3 moles of carbon monoxide in it, and for every 3 moles of carbon monoxide, I usually get 2 irons, but I don't have 3 moles, I have 107 moles, so how many irons is that going to make instead? So let me piggyback up a step. We had 3 kilograms of carbon monoxide. I converted that to moles by dividing it by its molecular weight. Based on the reaction I have, 3 carbon monoxides will always result in 2 irons. It's a 3-to-2 ratio. I don't have 3. I have 107. How much will 107 result in? You cross multiply and divide. So I'm going to do 107 times 2. 107 times 2 divided by 3. And you get 71 moles of iron. Question wants kilograms of iron. So I'm going to multiply this by 56 grams, because that's what 1 mole is. My moles cancel, and I get 3,994 grams, which is equivalent to 3.994 kgs, kilograms. Do you use table J for double replacement? Was just asked. No. You use table J for single replacement only. Table J is single replacement. Table F is double replacement, because you got to figure out who's insoluble. Cool. All right. That was A. Grams to moles, proportion in the reaction, moles to moles. Take the moles you get, convert that back up to grams, and then I just converted to kilograms because I wanted kilograms in this one. Okay, B. How much iron oxide is left after the reaction is completed. So we said carbon monoxide was our limiting reactant, which means we're going to run out of it before we run out of the iron 3 oxide. So after we've reacted everything, how much iron 3 oxide is left just sitting there because the carbon monoxide's gone. We got no more. So it's basically what we just did, but we just have to do one little extra step at the end. So we said 3,000 kilograms was 107 moles of carbon monoxide. The reaction has 3 moles of carbon monoxide. And for every 3 moles, there's 1 iron 3 oxide reacting. So how much iron 3 oxide is going to react if we have 107 moles of carbon monoxide instead? So they're in a 3-to-1 ratio, and you can probably already see right here, all I'm going to end up doing is 107 divided by 3. So you cross multiply and divide, do 107 divided by 3, and you get X is 35.7 moles of iron 3 oxide. Oh god, how much was this? I forgot how much it weighed. We said iron 3 oxide weighed 160 grams per mole. So we multiply this by 160 grams because that's 1 mole. Those cross out. And we get 5,712 grams of iron 3 oxide are reacted. Based on the question, it said we had 7,000 grams of iron 3 oxide available. So if you take 7,000 and subtract from that 5,712, you'll get 1288. That's an 8. 1288 iron 3 oxide not reacted. So just sitting there. So think like, I don't know. Let's try to think of a lab we did. Think of the lab we did where you like dissolved the magnesium in the hydrochloric acid. You took like a little piece of magnesium, you put it in a bowl of hydrochloric acid. There was a bunch of hydrochloric acid that went unreacted, but all the magnesium reacted to form magnesium chloride. So this happens all the time. You have one reactant that we purposely give you too much of, so the reaction we know as a teacher will go to completion. So you don't like sit there getting some answer that doesn't make sense. And this was B. I should change this to B. Yeah, that's the limiting reactant. Is there going to be a weird one like this on the test tomorrow or a normal limiting reactant one? I wouldn't say this is abnormal, so don't assume anything. Because the process to solve this is the same as the process to solve any limiting reactant. So, maybe. Moving on. Let's see, hold on, I'm getting a few more questions here. So yeah, back up to here. When you're setting these problems up, when you get to this step, anytime you do stoich, because this limiting reactant is just an example of stoich, you need to set up proportions based on the reaction given, where every single number you see up there is moles. Fe2O3 means for every 2 moles of iron, I have 3 moles of oxygen. And when you have 2 moles of iron and 3 moles of oxygen, they react. Carbon monoxide, for every 1 mole of carbon, I have 1 mole of oxygen. You get those ratios, react. The big numbers, for every 1 mole of this compound iron 3 oxide and 3 moles of this compound carbon monoxide, you get a reaction. Iron is formed, carbon dioxide is formed, and that keeps going until you run out of stuff, whatever one is given first. Okay, so this question is pretty identical to a warm-up question. In fact, you can tell from where I crossed out, it was a warm-up question the other day, but I forgot to change it. I probably came up with that warm-up the morning of and totally forgot I put it on here. Not important. Anyway, how many carbon atoms does a sample contain? So, this is a straight-up moles question. You have moles. Moles means three things. One mole is how much does it weigh on the periodic table. One mole means you have 6.02 times 10 to the 23rd molecules or atoms of that substance. And one mole means you have 22.4 liters of gas at STP. Gas at STP. You need those two conditions. Not 22.4 liters of liquid, 22.4 liters of gas at STP. So, we want to know how many carbon atoms this sample contains. So right off the bat, the first thing I notice, it's carbon dioxide. For every 2 atoms of oxygen, you have 1 atom of carbon. They're in a 2-to-1 ratio. So I know right now that the number of carbon atoms I have should be less than the number of oxygen atoms I have, because there's twice as many oxygens in this equation as carbons. So I have 2.41 times 10 to the 24th atoms of oxygen. There's a couple ways you can do this. Based on what I just told you, you kind of already see the answer. I just said they're in a 2-to-1 ratio. Take that number, 2.41 times 10 to the 24th, divide it by 2, you get 1.21 times 10 to the 24th. That's how many carbons you have, and you're done. That's it. The sample is carbon dioxide. They're in a 2-to-1 ratio. Divide it by 2. That's how many carbons you have. The end. Now, does that help you answer B? Now, B, if you want to say 44 grams, you can't say 44 grams because you don't know how many moles of carbon dioxide you have. If you have 1 mole of carbon dioxide, I would say, yeah, it's 44 grams. But since I have more than 1 mole of carbons, because 1 mole is 6 times 10 to the 23rd, that should be a light bulb going off up here that you have more than 1 mole of carbon dioxide. Because the only way I'm going to get more than 1 mole of carbon, since there's 1 mole of carbon in every molecule of carbon dioxide, I have to have more than 1 mole of carbon dioxide. And this has been hard to process. Something's going on here. And I'm trying to think of an analogy where this makes sense. Because a lot of people are getting this question on test day and going, how can I have more moles of oxygen in my formula than moles of my formula? And what I'll say is, think of anything that's made of parts. Think of a car. A car has 4 tires. For every 1 vehicle, there's 4 tires attached to it. The amount of tires will always outnumber the amount of cars because every 1 car has 4 tires. So every 1 molecule of CO2 has 2 atoms of oxygen. For every 1 molecule of H2O, there's 2 atoms of H. So your H's will always outnumber how many H2O's you have, regardless of how much H2O I give you. You have 1 H2O, you have 2 H's. You have 6.02 times 10 to the 23rd H2O's, you have double that amount of H's. And something about that in our heads is like, I can't have more H's than I do H2O's, where that should be the ridiculous thought. That doesn't make sense, because for every H2O, there's 2 H's. So what's the total mass of this sample? Well, if I take the amount of carbons I just determined, which is 1.21 times 10 to the 24th, and I divide that by the amount of moles, the amount of molecules, I should say. I'm trying to figure out how many moles of carbon I have. where one carbon dioxide has 1 mole of carbon. I'm trying to figure out, wait, I don't have 1 mole of carbon. I have more than 1 mole. I have 1.21 times 10 to the 24th moles of carbon, which gets us to 2 moles of carbon. So if I have 2 moles of carbon, because I have double the amount of carbon atoms, I must have double the amount of carbon dioxides, which means I have 2 times 44, 88 grams of carbon dioxide. I have 2 moles of carbon dioxide, and that makes sense because this 1.21 times 10 to the 24th is 2 moles of atoms of carbon, and 2.41 times 10 to the 24th is 4 moles of atoms of oxygen. Don't let that, you're making it complicated. You're overcomplicating questions like this. Because it was on your quiz from like February. It was on your STOIC test from February. And it's just something that is like not clicking. And I'm like trying to throw analogies out as best as I can for these ones. Okay, temperature change K, dissolved in benzene. There's a freezing point change, delta T. Now I gave you benzene. I didn't give you water, so don't be writing 1.86 anywhere because your solvent is not water. It's benzene. So we want the molar mass of the unknown compound. Molar mass is moles per gram. No, grams per mole. Come on, Mr. G. Been talking about chemistry all day. I'm losing it. So, grams per mole. So I need to figure out how many moles I have. Because I have 20 grams, but I don't know if that's 1 mole. I have no idea how many moles that is. Is that 1, half, 30, 4,000, 0.1? I don't know. I need to get moles. And that delta T equation has molality in it, which is moles of solute, kilogram of solution. No, kilogram of solvent. So, I have every single variable in my delta T equation except moles of solute. I don't have that. But I can get moles, and that amount of moles will say, oh, 20 grams equals this many moles. How much is 1 mole weigh? Boom. And then you're done. So, it said the freezing point changed by 3.77. 3.77 equals I. It's not an electrolyte, which means it's not ionic. I is 1. Times 5.12 is my KF. That's given. Don't be writing 1.86. I didn't give you water. Might not give you water tomorrow. Watch it. Times moles of solute over kilograms of solvent. Don't add that 20 grams in. It's solvent only. It's not solution. 20 grams would be added in if it was kilograms of solution, which it's not. It's kilograms of solvent. So, first thing I did was divide both sides by 5.12, and I got 0.74 equals x over 0.5, cross multiply, and you'll get x is equal to 0.37 moles. Moles. And that 0.37 moles is equivalent to the 20 grams. I dissolved 20 grams, and I've determined that that 20 grams is 0.37 moles of this compound we don't know. So if 0.37 moles equals 20 grams, where did I get the 7 from? How much does 1 mole weigh? It's a proportion. Your number should be bigger. If a third of a mole weighs 20, something bigger than a third should weigh something bigger than 20. So cross multiply and divide. You're going to do 20 divided by 0.37, and you get 54. I'm trying to like remember what I did this morning, if my key had any mistakes in it. And this, based on the fact that no one's... Oh, shoot. Yeah, you're right. I knew I made a mistake. I was like, gosh, darn it. Thank you. I got that 54, and I was like, that's not right. It's too late to do this. Anyway, the freezing point resulted in 3.77. The actual freezing point is 5.44. So it changed to 3.77. So if I do 5.44 minus 3.77, I get how much the freezing point changed, which is 1.67. Divide that by 5.12, and you get 0.33 equals x over 0.5. Multiply, cross multiply. X is 0.16 moles. 0.16 moles is equal to 20 grams. 1 mole is, I don't know. 20 divided by 0.16 is 122. That sounds better. Little boo-boo. Mr. G makes mistakes too. I make mistakes like all the time. Thank you to you for correcting me. So 122 grams. Final answer. All right, back to remind. Who's got questions? Will we be able to retake or correct the quarterly? No. It's final. You can retake any other test, though, at any other time. All right. Dilutions. You know, you're going to keep bothering me that question on the test was worded strangely. I'm going to say no. We were just not reading it right. But that's neither here nor there. To what volume? So we're looking for a V. Whether it's V1 or V2. Let's figure that out in a minute. Should you dilute 133 mils of a 7.9 molarity solution? It's a really strong solution. I need to dilute that to something else. To something else that's weaker than 7.9. And they didn't give us another molarity, but they gave us a volume, and they gave us a mass, and a molarity is moles per liter. Now, let me take a minute here. The questions you had on that solutions test last week, some of those short answers were pretty hard. The solutions retake has similarly difficult problems. I don't think they're going to have as difficult on the quarterly tomorrow. But those of you that started that solutions retake and the many of you that plan on retaking it, keep track of what your units mean. Because if you don't do that, you're not going to get them right. Because there is a problem awfully similar to that oxygen dissolving in water. And I give you units, and you need to expand those units, or you're not going to get it. Molarity is moles per liter. Not for this problem, but if I give you molarity, or I give you molality, and I tell you what it is. So if I tell you it's 5 molarity, or I tell you it's 0.1 molality, you can assume, and this is not a stretch of an assumption, but if it's 5 molarity, by definition, that is 5 moles per 1 liter. That's 5 molarity, period. You can't fight me on that. And that's not even really an assumption. That's just expanding out what molarity means. If I tell you something is 0.1 molality, yes, there are numerous ways 2 numbers can get you to 0.1. Really, like the 5 molarity, you can manipulate 5 over 1 in so many ways to get 5. But at the end of the day, it has to be 5 over 1 at some point. 0.1 molality is equivalent to 0.1 moles per 1 kilogram. You can't fight me on that. That's true. So those retakers out there, especially the ones that were taking it today and got to part 2 today, expand your units. You can't, that's true. You can't say I gave you 5 molarity and say that's not enough information. No, 5 molarity is plenty of information. You have 3 pieces of information: molarity, moles, and liters. And you've been converting moles for 2.5 months now. Liters, you can manipulate that using density. Solve the question right. Back to the problem at hand. I need molarity. And we just said molarity is moles per liter. What are you doing? Moles per liter. And you're going to say, Mr. G, you didn't give me moles. I gave you grams. And you can always convert grams to moles. So 10 grams of NaCl divided by 58 grams, because that's how much 1 mole weighs, is 0.17 moles. Molarity, 0.17 over 0.0705 liters. Please convert to liters. It's in the formula. Don't use milliliters. 0.0705, boom. 2.45 molarity is what I want. That is the goal. I have to take what I have, which is 7.9, 133 milliliters, and dilute that until it has a concentration of 2.45. The smart way to do this is to take your beaker, 133 milliliters, this is 7.9, take an empty beaker, pour some of it out into here, and then add water until it equals 2.45. I don't want you to do what you did on the test where I took 3 right answers. I want you to keep the 7.9 bottle you have, not ruin it, and just dilute it in a separate beaker so now you have 2 bottles of solutions that are usable. And if I look at these numbers right here, that looks awfully like something I can plug into an M1V1 equation. So I am given 7.9 molar M1. I am given 133 milliliters V1. I would like that to be 2.45 molar. What volume do I need to dilute it to get there? You divide both sides by 2.45. 7.9 times 133 divided by 2.45, and you get a V2 of about 429 milliliters. So, what does that mean? This is your final answer, because all I was looking for was what's your final volume? What if the question was, how much water do I need to add? So, if you have to know how much water you need to add, unfortunately, you're going to end up wasting your bottle of solution. If the question is how much water you need to add, and all you have access to is 133 milliliters of 7.9, realistically, you probably have an infinite amount of liters at 7.9 concentration. I want to know if you take 133, just 133, and put it in there, how much does the volume have to be until it's 2.45, which would be 429 milliliters, which means you would have to subtract those two, 429 minus 133, you'd have to add 296 mils of water, and then it's diluted. And that's what I do. So every time you work with acids, we have a huge, big jug. We have a big jug of acid, like 2 liters, and it's 12. And I need to dilute it to 6, 3, and 1. Maybe 2, not usually. So for 6, that's easy. 6 is half of 12. I take out the 12, dump out a liter, dilute it with a liter of water. Repeat for the other ones. Take the 12, dump out a quarter of it, dilute it, whatever I need to do. Is Stoic a big part of the quarterly? Technically, no. It's like a little bit of everything. I would say 2 questions. 3 maybe is Stoic. I can't like overwhelm you guys with Stoic problems. You need to know Stoic. It's a skill. I want you to show me that you may or may not have that skill, or I want you to show me how much skill you have to do Stoic. And I can't just give it to you 10 times, or else you're going to get 10 out of 10 right, or you're like, I'm somewhat skillful at Stoic, you get half of them right, or you're stuck with Stoic and you get none of them right. And then it's like, what is that? How does that benefit either of us? I could tell if you can do Stoic if I give you 1 Stoic problem. So not too many. It's an even mix. Like, how many parts per million questions are there going to be? Probably 1. How many molarity questions are going to be? Straightforward, 1. Application, maybe 1 more. How many moles problems are going to be? A lot, because there's questions where I can ask you how many moles, how many grams. You need moles for Stoic. You need moles for delta T. You need moles for molarity. You need moles for pretty much everything except predicting and balancing. So there's a lot of questions on moles. How many direct questions? Like, you have 50 liters of this. How many moles is that? 1, 2? But you need moles for everything. All right. Opening it up to you. Start requesting multiple choice, because there's 44, and God knows I'm not going through all these. There's a lot. If I had to guess, 41 probably sounds like a good candidate for how do I do this. So I'm going to start with 41, and I'll let you chime in. All right, 41. We have a solution, which by definition is a solute and a solvent, which by definition means I have some HBr, and I've dissolved it in something that I'm going to assume is water. We're getting molarity here. Actually, this is a good thing to bring up again. You know molarity is moles per liter. If it's moles per liter, 1 liter, you might as well just say, I have a liter of solution, because that's what molarity is by definition. So, moles per 1 liter, boom. I can do this entire problem now. I have the density. From the density, I can cancel out my liters. Then I'll have mass. From mass, I have the mass of the entire solution. It tells me the solution is that percent of HBr. Take the percent of that mass. Then I can take that mass, get moles. Should be done. So, 1.50 grams per 1 milliliter. I know we are assuming, and not really assuming, because molarity by definition is 1 liter. I got to multiply this by 1,000 to cancel out my milliliters, because we're assuming this. That's what I'm assuming. You have 1 liter, which is 1,000 milliliters. So that's 1,500 grams of solution, which is your HBr and what we're just going to assume is water, because water is pretty much always the solvent. Multiply that by 0.48, because I need 48% of 1,500. And you get 7 grams is HBr. It's a lot of HBr. But I want molarity. And molarity is moles per liter. So I need to get moles. And then I'm done. Because we already know we got a liter. Because the definition is moles per liter. So divide this by its molecular weight, which is given. And you get 8.89987 blah, 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 blah. You can round that up to 8.9. B. That's it. And this was on your solutions test last week. A problem similar to this is on your solutions retake, but it doesn't use molarity. Expand your units. These are not numbers. These are measurements. There's a big difference. You're like, but they're just numbers. Measurements have a meaning. Numbers in math, the sides of a triangle, have meaning in the real world if you're talking about being an architect. But on that piece of paper, they're just numbers. There's no units there. It's like, oh, there's this side's 5, this side's 4. What's the other side? No units. So don't just plug numbers into a calculator until you get an answer. What's another good one? You know what? I gotta do a stoic. Gotta do stoic. Because stoic is like balancing equations. Balancing equations, most of you thought weren't that hard. We can do hard ones, but the concept, once it clicks, you're like, okay, I'm just counting. Stoic is taking some time. Getting there. We're getting there. But man, is it a pain in the butt. If it makes you feel better, limiting reactants, the first thing we did after predicting products, I didn't get, and I took Chem as a sophomore, I took AP Chem as a senior, and then I took a bunch of chemistry in college. So I did not get limiting reactant to stick until like halfway through my freshman year in college. I was doing a homework assignment, and then all of a sudden, just like, why did this not make sense to me until now? So I'm not saying it's going to take you until your college for this to click, but it's okay if it's not clicking yet. Keywords yet. So let's do 43. I want grams. I'm given liters. I'm concerned with FeS2 and SO2. So don't care. Gonna ignore. Because who cares? The question doesn't concern those. I'm given liters of SO2, which means I have to go from liters of SO2 to moles of SO2. Then I have to compare the moles I calculated to the moles in the reaction. And I have to take the moles in the reaction and get grams of FeS2. This is why stoic is such a pain. So let's get going. So 11.2 liters of SO2. 1 mole is 22.4 liters. So that is a half a mole of SO2. Go to my equation. For every 4 moles of FeS2, I get 8 moles of SO2. So for every 4 FeS2, I get 8 SO2. But I don't have 8 SO2. I have half. How many moles of FeS2 do I have? Do a little cross multiply and divide. You should get a quarter. X is equal to 0.25 FeS2. Well, how much does 0.25 moles of FeS2 weigh? Well, FeS2 weighs approximately 120. So 0.25 moles times 120 grams is 1 mole. Moles go bye-bye. Divide that by 4. I get 30. Hey, didn't even have to round. 30. It's tedious. It's tedious. Tedious problems are annoying. Don't get them wrong because they're tedious. Treat them as like 3 separate problems. A lot of you, if I said convert liters to moles, you're like, got it. If I said convert moles to grams, got it. So take this stoic problem, take this complicated problem, and just treat it one step at a time. Problem 1, get moles. Problem 2, proportion. Problem 3, convert out of moles. Because if I said convert 11.2 liters to moles, done. If I said convert half a mole to grams, done. Piece it all together into one problem. Or, sorry, piece it all together into 3 separate problems, and then maybe that helps. Send me questions. Which ones do you want to do? Which ones are you confused on? How's table G? How's table F? How's table E? How's life? How are we doing? How's break? Plans coming up? Is Adele watching this from Australia? That'd be hilarious. What's new in your world that you would like to tell me about? I'm going to take a quick peek through here. Pick some of the other ones. Temperature goes up. It's all about collisions. D, not C. Eraser. There we go. I think Mrs. G is live stream. Oh my god, I cannot circle D tonight. D. Okay. I think Mrs. G is live streaming out there too. Questions, questions, questions. Who's got questions? Hey! I was like, nobody? Nope, we got some. Alright, whoa. Okay, goodness. I wonder if there's a little delay. Probably. 19 and 38. Boom! 19. Hey, so gas has a density of 0.717 grams per liter? Liter at STP? What is the molar mass? So, I see STP. I see molar mass, moles. I have grams per liter, STP at liters. 1 mole of STP is 22.4 liters. Now, if you don't remember exponents, -1 is the same as grams over liters. So I got 0.717 grams per 1 liter. I'm going to multiply that by 22.4 liters. Liters go bye-bye. And I get 16.1 grams. Whoop. Yeah, that's it. We hate density. 38. 38. Ionic radius is larger than its atomic radius. Negative ions gain electrons, oxygen. Metal ions are always smaller because they hate electrons. They're going away. I've thrown pens at the walls enough. Metals hate electrons. Whoa, phone is bugging. All right, what's next? 40. All right, so everyone's favorite question to ask. How hard is this going to be on the Regents? 40 is the hardest stoic problem you'd see on a Regents, theoretically. Moles to moles. All right, so this is 8.3 moles. I want to know how much CO2 I'm going to make from that. So if 2 normally makes 4, 8.3 makes, I don't know. How can you do this a quick way? Oh, CO2 and C2H2 are in a 2-to-1 ratio. For every 1 C2H2, there's 2 CO2s. So I just got to take the moles and multiply it by 2 to get 16.6. The other ways to do it is 8.3 creates some amount of CO2, but I know 2 makes 4, and you cross multiply and divide, and you get 16.6. That's it. That's the hardest stoic problem you're going to get in June, if you get a stoic problem. Next, 36. 36. Boop. 5 grams of KCl is dissolved in 50 grams of water at 25 degrees. The resulting mixture can be described as table G. All right, so first, it's 50 grams of water. and it's 25 degrees, and it's KCl, and it's 5 grams. So I'm going to go to table G. It's probably going to be a disaster. Disaster. 25 degrees, 5 grams is right. Yep, nope. Goodness, Mark, that's 20. Mark, Mr. G. Goodness, it's right there. Okay, so that's 5 grams, 25 degrees. KCl is right here. So, first thing it said was 50 grams of water. This is measured at 100 grams of water. So you essentially have to take this line and divide it by 2. So it's a little under 30, so pretty close to under 15. So the new curve is right here. Well, that, to me, is still under the line. And if you're under the line, you are unsaturated. So let's look at the answers. So these are gone. If you're saturated or unsaturated, you are homogeneous because it's all dissolved. If you're over the line, you've dissolved up to the line, and then anything above it is not dissolving, which means it's heterogeneous because it's not mixing. So I believe we said we were unsaturated and we were homogeneous. And the end. Next. 11. Parts per million. Parts per million. So parts per million is grams of solute, which was given. So 1.2 times 0.2 times 10 to the negative 3 grams of solute over grams of solution given, 800, times, you guessed it, 1,000,000. So take your grams of solute, divide it by your grams of solution. So 1.2 to negative 3. That's just 0.0012 divided by 800 times 10 to the 6th. And I get 1.5, 1.5. All right, what's next? Don't forget the million. Everyone forgets the frickin' million. Parts per million. Million. I know you did it in class, but I forgot what you said. Number 14. 14. Okay, so this is an M1, V1, M2, V2 problem. We want to make this, and we have 5 molar. So, oh man, I need more room. We're given 5 molar, and I want to figure out how much of that I need to use and then dilute. So I don't have a V1. It gives you M2 and V2. So this equals 0.1 times 100. It says, please give me this. This is what I want. I want a bottle at a concentration of 0.1 with 100 milliliters of stuff in it. So if I do 5 divided by 0.1 times 100, I get 0.5. Is that right? That doesn't feel right. Hold on. No, because I did that backwards. If I do 0.1 times 100 divided by 5, so show your work, Mr. G. Boom. Divide both sides by 5, I get 2. So V1, I wish I had more room. I'm just going to talk. V1 is 2, which means I need to use no more and no less than 2 milliliters of a 5 molar solution and then dilute it with water up to 100 so it has a concentration of 0.1. There's 2 ways to do this. It's multiple choice, and I obviously want to answer with 2 milliliters in it, so I'm just going to pick that one. Conceptually, however, why is it that one? What if another answer choice was 98 first and then 2? How would you know which one to pick? Again, you said your V1 was 2, which means you need to use exactly 2 milliliters of your 5 molarity concentration. And then you need to take that 2 and dilute it up to 100, and you dilute things with water, and you know what 2 plus 98 is? 100. 20-something was next. 27? 27. Yeah, so it should be... The 2 milliliters came from me solving for V1 here. I did 0.1 times 100 divided by 5, and I got V1 was 2. 27. First, a lot of you were making the incorrect assumption that the two things given to you in the problem were products. They were not. They are reactants. It says, what is the net ionic equation for the reaction between these two things? So you need to react them. So let's do that. It's double replacement, which means I'm going to take the 2 positive ions and switch them with each other. So Pb is going to be with S, and NH4 is going to be with NO3. Now, I know my solubility rules, and if you're taking the SAT subject test in chem, you need to know some of them, not all of them. And I know that NH4 is soluble with everything, and NO3 is soluble with everything. And your net ionic equation needs to be the 2 things that are not soluble. And if I look at my answer choices, all of them have NH4 in it, except A. And that's all she wrote. PO, process of elimination. Use it. 2, play the game. One of these things is not like the other. If you're doing a problem and it says the moles are increasing and 3 out of 4 of the answer choices have answers going down, you probably don't need to do any work. Questions, questions, questions. 3, 2, 1, go. I'm going to give you 30 seconds, and then I am signing out. I guess I should get Harper, because everyone's like, Lindsay, don't. Where is she? Harper, where you at?
Where? I'm in the middle of recording.
Oh, I thought you were doing a live session.
No, I'm recording a video that I needed to upload an hour ago.
Harp, come here. Hey, come say hi. Come here. Come here, girl. Come here.
She's in bed.
I know. She's going to get out. I'll get a treat. I didn't know. I'm sorry.
Okay, I still need to finish.
I'll get over here.
Love you.
Hey, what's this? Oh, yeah. I get up for food. Hey, girl. Hi. Can you sit? Would you give me paw? You'll give me other paw? Yeah. Up. Up. You can do it. There you go. Good girl. Yes, Harper. Harper's the best. So you know. Alright, I gotta finish. Thanks for saying hi. You did good.
Judy, you're off my roof.
Go say hi to Mom. Don't listen to Mrs. G in the background. She's talking about. She did. You should catch one of your bats on live stream. They're in the wall. I'm not catching any bats. Will the multiple choice and short answers be separated? Yes. Use your time efficiently. I'm not gonna let you take 10 hours to take this quarterly. Multiple choice will be separate from the short answer, mainly because you're losing points because you're wasting time trying to get a 2-point question right. And then losing 10 points because you're not focusing on the multiple choice. So you're getting the multiple choice first, period. And when you are done, you are turning it in and you cannot get it back. So do the multiple choice, don't waste time, get points. I'm not breaking through the wall to find a bat. Crazy. That's also not how you get them out of your house anyway. You can get them out of your house once they're in your house, like not in the walls. But you gotta install like a one-way door on the outside of the home, and then they leave, and then they can't get back in. And they're not that smart, so they're gonna come back the way they've always come back, and like, I'm trying to get in the house, I'm trying to get in the house. And then they can't. And that's what's unfortunate. 17. Successful collisions. So this question's basically saying, how does a reaction occur? You don't need a catalyst. It's nice. You have a bunch of catalysts in your body because you have a bunch of enzymes. And if you didn't have enzymes, you would be super dead because your reactions would take forever. So catalysts are good. They speed things up. They lower the activation energy and speed things up, which is nice, but ultimately not needed. So D is gone. See, so last night it devolved into Fortnite conversations, and tonight it's devolving into stupid bats. So what do you need for a reaction to occur? 1, they need to collide. If you don't have a collision, if the things are not reacting with each other, they're not going to react. So B is gone. 1's a big check. 2, you need energy, because guess what? If you don't have energy, they will just sit there and not move. So, energy is important. A is gone. C is gone. So, by process of elimination, good old Poe, your only option is E. Test-taking strategies, process of elimination. What does 3 mean if, like, process of elimination is just not your thing? 3 means, are they facing the right way? Think of, like, enzymes from bio, lock and key. I have a key, and even if I have a lock, and I know the key goes in that lock, if I keep putting it in the wrong way, it's not going to open the door. It's the same thing with chemicals. For them to react, they have to hit each other at the right orientation, the right geometry, to have an effective collision. Or else, you're just sitting there waiting. So this is why reactions aren't, like, instantaneous. They aren't, like, spontaneous. Some are, but they aren't, like, so fast it happens, like, in an immeasurable amount of time. It's so fast. They happen in a time. We're going to start kinetics more and more as this month goes on. You can time these reactions, but the reason that they take so long is you need that energy, they need to collide, and they need to collide appropriately. I'm not smoking them out. One of the bats did get in the house, which is how I knew I had bats. And this happened a few months ago, and I think I told you guys. And no, I didn't get Fortnite Mobile because I need to delete. I don't have enough space, and I just don't think I care enough to get it. So I'm not going to play at work, and then I'm going to play, like, when am I going to play Fortnite Mobile anyway? If I'm going to play games, I'm just going to play them at my house on a PlayStation. Yeah, so I knew I had bats because I found one in my washing machine, and then I may or may not have drowned it. What are the trends on the periodic table again? So this is good to know for the SAT2, aka playing the car on my way home. That is not safe because I drive. Don't forget. You're like, but if you're a passenger. The trends. 1, look them up on table S. 2, you forget to do that for some reason. This way, we got ionization energy is going up, electronegativity is going up, atomic radius is going down, metallic character is going down. This way, ionization energy is going down, electronegativity is going down, atomic radius, metallic character is going up. Yeah, because the iPhone 6 is terrible. The iPhone 6 was one of the worst set of iPhones ever released. Especially when iOS 10 came out. Totally, like, destroyed. Like, I don't even know if the iPhone 6 is, like, understood how to even process iOS 10. Or maybe iOS 11. I'm pretty sure it was 10. Doesn't matter. If you have a 6, you're better off just downgrading to a 5. Or just buy the SE, which is, I think, the 6S, but in a phone that doesn't suck. It was the most sold because it was when, like, the 6... It's when they introduced, like, the Plus model. And they were like, ooh, we can get a bigger one now. And it was right... Like, the 5 was pretty revolutionary. And then... So, if you bought, like, the iPhone 4, you had to wait to upgrade. Because it was back when you had contracts. So then when everyone's 4s expired, they were like, oh, 6. Yes. I'm not playing squads with you. I'm not playing games with you. Stop asking. I'm not playing in the car. That's not safe. 25. Two-gram sample of helium at STP occupies. So, helium, I believe, weighs 4. I like never talk about helium because it doesn't react. Yeah, it's 4. So, I got to get moles. So 2 grams of helium divided by 4 grams per mole gives you half a mole. And half of 22.4 liters is 11.2. Moly, 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 moly. Bent. How do you bend your phone? Hilarious. Was that the model where bending was a problem? Now I'm trying to remember. There's like one of the models where either bending was... An antenna was an issue at one point. It might have been the 6. The 6 had a lot of issues. Trash. Garbage. 7 was okay, I think. 8's been doing okay. iPhone X is not selling too well because it's like $1,000, which is stupid. The volume button. Yeah, that's life. Phones bend. Now, I think that was an issue with the 6. Now that I think about it. Because I remember watching reviews when it came out, and they were like, oh yeah, it like bends. 6 was trash. What kind of word questions should we expect? Like not involving numbers. Stuff about rates, like increasing the rates of reaction. How can a reaction go faster? Like dissolves like. What did I give today? They had a lot of number ones. I don't really know. That's about it. That's all I can really think of. Like stuff from kinetics and solutions. Periodic trends might be a word problem. Not a word problem. A short answer. So watch out for that. That's really all I can think of. This third quarter is big on the math, if you haven't noticed. Like predicting products, crisscrossing charges, moles, 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 molarity, moles. So, a question like 32 could or could not be a short answer. Probably not, but it could be. What's a periodic trend? So periodic trends are the trends that you see on the periodic table, which is this stuff. So what's the trend in ionization energy? What's the trend in electronegativity? What's the trend in atomic radius? What's the trend in ionic radius? What's the trend in metallic character? AKA, how metallic are you? The closer you get to the metals, the more metallic you are. So neon, not very metallic. Francium, super metal. Those are the trends, which I probably should have made you memorize, but I didn't. So you can kind of look them up on Table S. If you do go AP one day or you do go chemistry subject test, SAT, you need to memorize those. You need to memorize those for the subject tests in AP. You need to memorize like all of these for AP, but not all of them for the subject test. So subject test, you're pretty good here. Phosphate, sulfate, halogens. Those are the big ones they ask about in the subject test. I highly encourage you memorize all these for the subject tests, but the popular ones are usually what you're going to see, which is these guys, carbonate, ammonium. If you're going to take the subject test, buy the Princeton review book. It's the best one, in my opinion. I think it's the best at practice, and I think it's really good at making it not feel like you're reading a book. Like, I feel like it does the best at attempting to teach you using words and not a person. Yeah. No, just get rid of your iPhone 6. It's ridiculous. Duke sucks. iPhone 6s suck. I can like rant for days on certain things. 7. Least likely, you're looking for a noble gas because they don't react with nothing, though some of them do. That was a question on your quiz once, and that's neon. Carbon obviously reacts with stuff. It's like all of organic chemistry is carbon. Your body's like all carbon and water. Fluorine and lithium are unbelievably reactive. Lithium is super small, metallic, and would love to get rid of its electrons. Fluorine is also very small, non-metallic, and would love to take electrons from anybody willing to give them up. So they're very reactive. Yeah, I'm just giving you a hard time about the iPhone 6. I'm going to take this and ride it to the ground. Like, literally, if it doesn't turn on anymore, I'll buy a new phone. Because phones are an unbelievable waste of money these days. I hate phone companies. So, phones, when smartphones first came out, data was unlimited for everyone, period. What plan did you buy? You bought unlimited data. That was your only option, and it was much cheaper than it is now. And then the jerkheads were like, well, people barely use more than like 4 gigs on average. So they got rid of unlimited and came out with plans. And as smartphones got better and better and better and more popular, people started overshooting 4 gigs pretty much immediately. Like, one student told me they use like almost over 20 gigs pretty much every month, which means you are Snapchatting way too much. But now they're like, oh, well, since people need more data, we might as well just have unlimited again and charge you like 4 times what it used to be. Jerk move number 1. Jerk move number 2 is they used to have contracts for phones, so your phones were subsidized. So you would pay like $200 for a 2-year contract. You had to keep your phone for 2 years, but you paid like $200. Versus now you have to pay for the phone itself, and they try to market it to you as, but it's only like $30 a month. And like $30 a month, that's $360 a year. That's like $720 for a freaking phone. It's ridiculous. So now Verizon, which is the network I have, your options are 8 gigs is the biggest they offer, or unlimited. And I'm like, I don't want to pay for unlimited. Can you give me like 10 gigs to share? Mrs. G and I are not using more than 5 gigs each a month. And they're like, how about no? It's the worst. They're like, why don't you switch to AT&T? AT&T is almost no better. And then Sprint sucks, but it is cheaper. All right, last chance. Questions. Questions about chemistry. Questions about life. What's going through your head? give you 10 seconds. 10, 10, 10, 9, 9, 8. Don't stress. I'd have to say Wazowski blinks. I feel like a wink is not closing one eye. I feel like a wink by definition is one eye's closed, one eye's open. And you get that, classic wink look. Wazowski only has one eye. So you're basically asking if Cyclops' blink or wink. And I don't think Wazowski or a Cyclops has the ability to wink because they can't have another eye open as that one eye is closed. That's my opinion. All right, I think we're good. Don't stress. Take your time. If you normally do well, like if you've been getting A's on every test so far, you'll probably be fine tomorrow. If you're like in the I would like to improve my grade category and you're in the B's, you really got to take your time and really check your answers, check your units, check your work. If you want to improve and you're below a B, I'm going to give you the SAT test strategy, which is if you don't know what to do after about 30 seconds, you got to move on. And you need to go through the whole test and earn points that you know you can earn on everything, and then circle back and do the rest. Or else you're going to get stuck on that one question, and you're going to waste time on this one question, and you're going to run out of time because you could have earned points on an easier question. Because the test doesn't, aside from the short answers I'll create, which is always at the end, the multiple choice and the other short answers are just like a mixed bag of hard and easy. So skip around. Just try to do better, because if you're like, oh, last test I got like a 50, solutions is really hard, and you retake the solutions test, your goal should not be to earn 40 more points to get a 90. I'd like you would like to, but that's hard. And it's the same way with people that take the SAT, get 1,000. They're like, oh, I want to get a 1,300. 300 points is a lot. Baby steps. Take baby steps. I don't even know how to pronounce his name because I didn't grow up watching him. I think his name's Caillou. He's a terrible human being. And he's bald because maybe he has a disease, maybe not. But I'm going to assume he doesn't have a disease. And he's bald because he's awful. He's such a brat. And he's a terrible influence for kids. But chances are he probably has a disease, so you shouldn't judge him that much. But he's still a brat. All right. That's all she wrote. I'm going to stop this session. I'll see you tomorrow. Stop by anytime, morning or before class, and I will happily entertain any questions.